Now in chapter 5, integrals. Okay, in this chapter, we start with, in this chapter, we will deal with the idea of definite integral, which is the basic concept of integral calculus. This will be used to solve problems concerning area, distance, volume, length, population prediction, forces on a dam, water pressure, work, center of mass, etc. Consumer suffers, etc. So it has a lot of applications. Fundamental theorem of calculus that connect integral calculus and differential calculus will be the central concept in this chapter 5. Area problems. The area of region is computed as the limit of the sum of areas of rectangles. You have learned the 구분구적법. That's what it says. Okay. Let S be the area of the region here under the curve y is equal to f of x, which is a continuous function with the vertical line a and b, x equal a and b, and this is the region. Then, when we try to find the region, we may divide it as triangles or rectangles, and then find each area and adding up. That will be one way to do it. Okay, if you know how to find the area of the rectangle, you know how to find the area of rectangle, then you can divide up a polygon into a bunch of triangles and find the areas of each piece and adding up to get the whole area. Okay? That's the way that you have learned. So in case of area of a region, which with the curved side, we first approximate the region by rectangles, and then we take the limit of the area of these rectangles as the number of the rectangles increase. That is 구분구적법. Okay? Like this. If you want to find the area here, then you divide it and you make rectangles, approximated rectangle, and find the area of rectangles and adding up. Then you make more and more rectangles to get a better approximation. So that the region R of n can be found the height f of x1 and f of x2 and f of x3 with the distance delta x which is equally divided. So the base of each of these rectangles are delta x. So you just find the area of each rectangles with the height times base. As n goes to infinity, if we have more and more rectangles, then they divide. Then the area Rn will approach to the area that we are looking for. Okay? So if we make more division, more divided region, and then limit it, then that will be this one. Okay? So the Rn will converge to the area that we are looking for. If we choose right-hand side height, then we can use Rn here. If we use the left-hand side height, like this, left-hand side height, then we may use Ln instead of Rn to limit. But eventually they will converge to the same number area, same area. So in between, since they will converge to the same limit, so we may choose any sample point xi star in ith in the ith interval xi minus 1 and xi. So since they will approach it to the same limit, so even though we choose any number in between, x1 star x2 star in this interval, and it will eventually same. So this 1, 2, and 3 can be written as what? Can be written as this or this or this, but they will be all same. Okay. So we may show it in here. Okay. We may copy it. So we may copy it and chrome and here and then here. This is a Riemann sum. Will be called the Riemann sum. So, for example, if we have what sin x, then if we divide it, if we use a right hand height, then we have this right hand height here with the distance. So the area can be found the base times height, and add all those. That's about what 1.95. And so, but real area is 2, so this is an error. If we make it more region, then it will approach it to closer to the limit, so the error will be getting smaller and smaller. Okay, like this. Okay, and if we have the other function like cosine, then cosine, then, yeah, let's see what happened. Then we have cosine function. Since this is an odd function, this has the same area above the positive and negative area, so eventually integral will be 0. And so we can find the area with this right hand, using the right hand height and left hand height. If we divide it by 2, then what it gives us what? Then this will give us the area like the 1, and the right approximation is like this. If we use the left hand height, then that we will have the left hand, the limits, as we divide it to the more rectangles. Or we can even use a midpoint, like any. Then we have a slightly better approximation. Or we can use trapezoidal rules that you have. Like if trapezoidal rule is we are using this trapezoid to approximate the areas like this. This is a trapezoid. Like 사다리꼴이죠. 사다리꼴을 이용해서 하는. 그러면 we have a much better approximation. As you see, if we go at about 617 like what we did, it is almost 0.999. So there's almost no errors as it goes to infinity. So we will see. So these are the ideas of 구분구적법. Okay. So yeah, we can easily estimate those approximations. Here is some. Here is what you can do on the problems in the exercise problems in chapter 5. Okay, here, Control V. Oh, did I copy it right? No, did I copy it right? Here, link. Link was made it differently, but I can just copy this address and I can add it in here, and then you will find out what the area. The graph is what x to the fifth, and from 0 to 2, so you can easily estimate the area here. So use the same code to evaluate it by the rules. You can use the code that I have used here to whatever like to do. You don't even have to make a type it. You can just copy and paste it and make some modification. Here to draw the graph. Here, the same thing. You can find the sum and find the limit of it to find the right sum and the left sum. The 구분 구적법. You can do the same thing with this code. You only need to find the sum of it and simplify it, and then just find the limit of it. Then write it in the way that you like to. If you need to understand this word, all you have to do is here, expand, for example, or simplify if you want to see it, then okay, copy here, and if you go here, and in here, if you you may ask, you may type it here. If you have a curiosity, then you can just ask a question. Then it will give you the usage of those. If you wanna ask more on what integration, then you just ask a question. Then you will see how all the details of command, so that you can find the copy here. Then add it here. Then give a function. Then you will be able to use it. So, and also if you click with the escape key and click here, then you will find 여기서 여기에 설명을 보탠다. You may add the explanation of your code in here, and then you can publish it. You can publish it that after you save it. Okay, anyway. Okay. So yeah, Mr. Shin will give more detail in a new page. Will publish it. So you can use the function of the SAGE to deal with the other problems. I think that's for section 4.1. Is there any questions?